what we're going to go through today is basically every last single connection type that rigging has, minus a handful. So we're going to take a look at all these different ways to make things move today. Now, with that said, I am the type of person who feels math is taught wrong in school, and this feels like math to me. I'm showing you how to solve for X, how to solve for Y, but I'm not showing you in context. So I have two other files that I'm going to share with you guys. I'm going to show you guys the practical application of each of these on this little character rig. In reality, I'm not even going to show you guys the practical application of all of them on this rig because there are some things that I've never used. So I'll be transparent about that, and I'll talk a bit about that when we get there. It's good to know. So I'm not going to say you guys don't need to know it. The first step of being able to do anything is awareness. So it is valuable you're aware of it. But I will kind of give you guys, heads up that some of these things just aren't used. And then finally here, I have a complete built rig that I will show you guys kind of the final function of on some of the things that I'm not necessarily going to be able to apply here manually. So that's going to be what we're going to tackle today. So let's get started and kind of dive in with our first one here, which is going to talk a bit about parenting. And I think it's hilarious we get to talk about parenting in this field because it's a completely different context than what parenting actually is. So if you guys remember, parenting is the formation of essentially a hierarchy. It's the most simple way to do it. And the way I explained it is the use of groups inside of Maya. Groups form a hierarchy. Whatever's in the group goes underneath it. This is where, our stuff goes. And basically what it allows to happen is when this group moves, this stuff moves, but more importantly, the child and the parent remain independent. So what that means is that this stuff can still move within the context of the group. Now, I have a little folder here called parenting, and I'm going to show you guys a couple different ways we can parent so you guys are familiar with most of them. When you have something very simple like this, you can just use the outliner and you can middle mouse button drag underneath things. So for example, let's say I wanted the cone to be under the cube. I wanted the cube to move, and when it moves, the cone moves. If I go ahead and select the cone here and just middle mouse drag hover to where there's a box around the cube and release, that will parent. And what you'll see now is this is parented under the master group parenting, but we also have the cube here, and underneath that's the cone. And just like I showed, the cube now controls the cone, but the unique aspect of parenting is that the cone maintains the ability to move independently, and the cube can move and the cone can move. It kind of carries it along with it. Now, hopefully I froze these transforms and they return to the same spot. Otherwise, this is going to get messy. Moment of truth. Cool. One of the things I didn't talk about is unparenting. Now, how do you make them divorce, so to speak, or orphan? I don't know the term here. The way you can do that, simplest, is with the hotkey Shift-P, but you can also try fighting the middle mouse drag method. So you can unparent manually by coming over here to the cone and trying to drag it to like one of these cracks in between and releasing, and that will also unparent. So that's kind of the manual way. Touching base on the hotkeys, the one I showed you guys the other day, there's the hotkey setup where you do child parent P. So child plus parent plus P. So first selection is the child, second selection is the parent, and then finally you press P and that does parenting. So let's say we want to do the same thing. We wanted the cone here to be a child of the cube. We could select the cone, shift select the cube, and hit P, and you'll see that will parent. This is going to be the way that I will be parenting, just so you guys know. It's the fastest way, most efficient way, doesn't really require the user interface, but it does require a bit of confidence in what you were doing. So I do like to show the middle mouse drag method. There's one other way I'm going to show you guys that I also use a lot, but you'll see it's now parented. Now, I already mentioned this. If you want to unparent, you simply select the object you want to remove from the hierarchy and hit P, Shift P, excuse me. So if I wanted to remove the cone, for example, if I select it and hit Shift P, it's going to unparent. And you'll see it's now outside of here. Notice it just completely removed itself from the parenting hierarchy altogether. That's going to get out of there. Now, I mentioned I use the P hotkey a lot. That's for things I can see. When I can't see things, for example, I can't see the group here, I will use the middle mouse drag method. So those are two of the ways that we can do parenting. There's a way up here through the mysterious menus, but that's just where I don't go. Menus are gross. Don't go there. You guys can probably look it up if you really want to know. Why, I don't know, but hey. There is one thing I do want to show you guys, though, which is a special menu. It's underneath here in the windows, and it's something called the, I'm probably going to spell this wrong, hypergraph hierarchy. I'm not even going to try and write it out. It's hypergraph hierarchy. If you come in here to Windows and you come into the general editors here, it's going to be located right here. Now, what the hypergraph hierarchy is a outliner that is horizontal. That was a not very elegant way of saying it, but that's essentially what it is. So when you click on the hypergraph hierarchy here, you get this screen, which is really big. But I have two monitors. For those of you who have two monitors, usually how I work with rigging is this bad boy is sitting over on my other monitor over here. Now I'm going to feel very claustrophobic, like I'm sitting in a airplane seat having it on screen here. But what this is essentially showing us is just another version of our outliner. Notice, however, it's just showing us the nodes within our scene. All I see here is my groups and my cubes. I'm not seeing things like the cameras or anything like that. You can bring that kind of stuff in here, don't need to. The other thing I want to mention is there is a whole bunch of bells and whistles up here that we just don't need. In other words, this can do stuff, but you rarely use it. There may be a situation where I show you guys using this. I really don't use them very often. Mainly, it's just nice to have this view. This view is just nice. It's easy to see. Now, why is this view nice? It's a little bit more intuitive. So this is our parenting cube here. You can see in here, I can just middle mouse click and move things around. Where that did is it put them all the way back here. But this is the other way you can do parenting. You can do it through this screen. And you can use either the hotkey or middle mouse drag. So for example, I could middle mouse drag this cube on top of parenting here. I could go ahead and select the cone here, shift select parenting and hit P. If I wanted to put the cone under the cube, I could shift select that and hit P. All right. And those are all different ways we could get that set up and parent it. So pretty cool, and that's parenting. So parenting is going to be one of the most important skills that you end up developing as you work on rigging, and it's one of the fundamental, tools to kind of get things up and running. Now, the next thing we need to talk about is going to be parent constraints to kind of make these a little bit different. So let's go ahead and jump over here to my parent constraint file. You'll see it's a ways down from here. Now, parent constraints pair with parenting, but they do so in kind of a different way. That idea of a constraint, it means to kind of restrict or to limit. So for those of you who are hyper-controlling parents and you don't want your kids to maintain independence, and you need to strap them down with a rope, this is for you. So the way this one works is you select the parent first, or what I call the driver. You shift select the driven, and you find your way to a constraint menu. Now, you might notice I'm on the rendering tab, and constraints don't live here. So when it comes to the rigging tools, there's two menus we commonly find those under. Obviously under the rigging tool, and then obviously under the animation tool. Now, some fun historical facts for you guys that is just weird and good to know is in the past, I don't think constraints used to live under rigging, which is funny. They used to be under animation, so you had to toggle between these a whole bunch and vice versa. It's gotten a lot better. Generally speaking, when working in rigging, you'll be under the rigging menu. So once you have selected these two, you can come over here to constraint and you can select parent. And if you go ahead and click that, what it's going to do is it's going to make it now so that this cube is making that thing move. Now you might notice, hey, there's something weird going on with that. What is that? This is a fun fact that after you do rigging, a lot of the times it's important to come in here and reset your settings. So if you come into the constraint box here, you'll notice that I have messed around with some things at some point for some reason. If you guys ever need to get back to the defaults on any tool in Maya, you can come up here to Edit and Reset Settings, and that will go ahead and reset it all back to the default. And if I go ahead and hit Apply now, it'll do what it was supposed to. You'll see it's controlling that. Now, let's break this down a little bit more. I know I did a lot of filler in there. I'm going to hit undo. Just to kind of get the base steps in, it is select the driver, shift select the driven, constrain parent, and now they're hooked up. So this guy is going to control that. Now, a couple things happen when we use constraints. A new node is created, which is going to be the little red chain that you see over here in the hierarchy. This here is our constraint. This is significant because it is a node with attributes just like any other node in Maya, and it means we can edit them if we need to. The other thing I want you to notice is the hierarchy is maintained, meaning that in the parent setup here, the cone had to go under the cube, but in the constraint, it ignores hierarchy. And this can be important for creating things called broken hierarchies, which allow us to do some interesting stuff. And I'll show you that in a second here. Now, some other aspects of constraints to be aware of is they will create a blue color in the channel box. So when you see blue in here, that means it is constrained, and it essentially means it's something you should not touch. So don't touch it. And then the other factor is don't keyframe it. That's a big, big factor. You don't keyframe on constraints because it essentially breaks them. It makes them so they stop working. So anytime you see that blue, just know not something you're supposed to keyframe. If your rig's set up correctly, you'll never see that blue, but there's some janky things out there. The other thing to kind of be mindful of is any changes this makes. You'll see it does have the ability to be changed over there, but they don't get recorded. So the moment I nudge this, you'll see it snaps right into place. And that's the difference between a constraint and a parent relationship when it comes to parenting. So parent constraint versus parenting is parenting. Your child has freedom. It can run around. It can be free. A constraint's kind of like being in school. They're strapped to a desk and they're not allowed to move. So that's the idea there. All right. So this will move, rotate, all that fancy stuff. Now, let's put both of these into context. I had to show you both to kind of even show you one in a practical context. This is a base rig that I put together, and basically what I've done is I've gone ahead and skinned this to joints. That's what these things are that you guys are seeing. We'll talk about those later on. We don't really need to see them at this point, so I can hide those, and you'll see that the controls are set up to control this. Now, I actually do need to see the joint here to show you guys how the constraints work. The way this is working is this controller here is constrained to this joint. Now, remember, we're not supposed to animate on our constraints. So what this allows us to do is create something that not only controls the little stone shard here, but something that controls the control for the stone shard. And it creates a level of separation so that we can keep things nice and clean and so they don't break. So you'll see that the blue's there on the joint because it has the constraint, and the curve here has nothing on it, so it's free. Now, this brings us to what we need to do to make that happen. This is where parent constraints come in. We want to keep our curve hierarchy separate from our joint hierarchy, separate from our geometry hierarchy. So to maintain that level of separation, rather than using parenting, we use constraints. And the reason why is so we have the ability to do stuff like this, where we can turn off the visibility of something like the joints, or something like the controls, or something like the geometry all independently. If they were interlinked into the same hierarchy, we wouldn't be able to do that. So what we essentially do is we take our curve, we shift control the joint, and we just do a parent constraint, make sure it doesn't have anything wonky, and hit apply, and now this will move. Now, where parenting comes in, if you guys remember, is once we have all these set up, they're independent of each other. They're not in a hierarchy, so we need to actually come in here and rebuild the hierarchy. Now, the hypergraph hierarchy I showed you is very helpful for achieving this when you get to this level of complexity. I'll come in here to my general editor, hypergraph hierarchy, but you'll notice that these curves all have something in here called an offset group. Now, this offset group will make a bit more sense once I show you guys some of the other tools and how they are set up, but these offset groups serve several purposes. The first purpose is they store the rotation information of the joint. Now, in our particular instance, I don't have it set up to do that because all of these joints are just set to the world orientation, but on a more complex character, we would need that. The other reason is we can put constraints on these that move the entire hierarchy that the control's under, but we can still animate the control. So it's kind of a neat trick where we could have two things influencing a single area. Now, what I essentially need to do is I need to take all of these and parent them underneath the torso control curve here. But what I need to make sure I'm doing is I am taking the offset group and parenting. So this is where it can be helpful to have something like the hypergraph hierarchy, because if I select something like this group here, I can click here to select the offset, and then I could select the main curve here and hit P to parent. And you can see how these menus aren't independent of each other. I can use this here to quickly kind of locate it, find the offset, shift select here and hit P, and do the same for each of these. So you can see very quickly, come in here, shift select and P. And you'll notice a lot of rigging is really just repetition. Once you've done one thing, you might as well go through and do it for everything. So that way they're all moving in a sequence here. Now, I'm not going to do this for all of, I'm not going to fully rig this character, I guess is what I should say. I'm going to just demonstrate this one here and then a handful of other things on it. But there we go. And then this final one here, this control, its offset needs to go underneath this global control. And what we end up with is this really nice rebuilt hierarchy here that represents our joint train. So you can see it looks similar to that. And now they should all be moving hierarchically and being controlled by the controllers. So we have the basis here of rig. And like I mentioned, we could stop here. This is a rig. You really don't need to do more than this to hand it off to an animator. Anything else you do from here makes their life easier. So yeah, there you have it. But that's going to be parenting constraints and parenting just in general. So we're going to take a look at some more abstract things next, but those are kind of the basics. Let's continue down the list here of abstract ways we can make things move. So the next one I'm going to talk about is direct connections. And direct connections are interesting because it allows us to pipe one object's information into another. Now, it's similar to a constraint, and what I'm going to show you will make it seem like a constraint. So let's go ahead and take a look at that. If I come in here to Windows and we go into General Editor and we come into this menu here called a connection editor, this will allow us to essentially connect the data of one thing to another. So I'll go ahead and open this up here. The one on the left is the output. That is the data that is going out. And then the one on the right here is going to be the input. That's the data that is going in. So what that means is whatever information's piped into here will be directly put into here. So if I come into this object here and I want this to be my output object, the cube, I can click reload left. And what you'll see here is at the top, we see the name of the object. So it's pcube1. And we see all the information that we can send out. Now, if we come into the cylinder here and I go ahead and reload right, you can see that it's going to reload the right information. The reason why this is useful as a base level is it allows us to connect things that there aren't constraints for. So for example, let's say I wanted the visibility of this cube to turn off the visibility of the cone. I could navigate to where visibility is by either scrolling, or I could type in up at the top here, visibility. You'll see I have access to visibility here, and I could do the same thing over here. And once I connect this, these are connected. Now, this is one of the weird things about direct connections is it's literally just in this menu. There's no external little connection node like a constraint. It is a direct piping in of data. There is no gate controlling it. There is no additional node. What you also notice is in a direct connection, if we take a look at the channel box, it turns yellow. So we have different colors here that are going to color code these areas. Now, to see what this does, if I come into this cube here and I set the visibility to off, you will notice the cone also disappears. So this is how direct connections work. And there's a lot of different reasons you might use a direct connection in a rig. Sometimes it's to directly connect one attribute to another. Other times it's to connect one unlike thing to another like thing or some singularity without needing a constraint for whatever reason. So it just kind of varies. So the other thing I want to talk about too is if you guys want to undo or remap or accidentally map the wrong thing, unclicking off of here also breaks it, but you'll notice if I just click this, you'll see it disables that. So there you go, off on. Showing you guys kind of the practical example. If I come into our final rig here, this control here, I set up the scale here to scale the joint. So as I scale this control, this joint scale data is actually changing. Notice the size of the scale doesn't change. This is a very weird thing about joints, is technically the radius is what we see. The scale is simply a transform. And you're not really supposed to animate on the scale if you can avoid it, because it can cause issues. But you can see I can use this to kind of make it bigger or smaller. And that's a direct connection there of this thing's scale values going into this. The only reason you'd want to do this is, I don't know, you could use a scale constraint instead. I just don't like scale constraints. So there you have it. Now I want to show you guys the actual useful way of using the connection editor. Like I mentioned, direct connections, they make sense for things like visibility that we don't have a constraint for, but there's other things that we can do with these, and that's to connect things to control things that aren't the same thing as them. There we go. We'll go with that. Essentially different attributes. So let's say I wanted the spin of this cube to control the translate of this here. And let's be specific. I'm going to do the rotate Z here. So we're going to make the rotate Z affect the translate Z. All right, so I could come in here and I can come into my general editor and connection editor. I could reload left on this guy, reload right on this guy. I'm going to look for my rotates on this one, and I'm going to look for my translates on this one. Remember that there is 3 inputs here. So if I just do rotate to translate, all of the rotates here will control all of the translates, and all of a sudden that thing's zooming all over the map, and that's not what I want. So I'm going to unclick these. And instead, I'm going to hit the plus icon and find the specific one I'm looking for. So I'm going to specifically take rotate Z. Over here, you'll notice everything is grayed out, but if I hit the plus icon on translate, I can come in here and grab the translate Z. And you'll see now it's just the translate Z. And if I take this now and rotate this, you'll see that this moves forward and backwards. Now, we'll probably have to put some sort of a modifier on this to make this actually function the way I want it to, because this is not exactly giving me a good result one-to-one. But you can see as this spins, that is going to move further away. So in a certain context, you could see how this could potentially be used to create something like a steering wheel that, you know, steers a column, or a turnpipe, you know, that makes something go forward. I don't know. There's some practical application. But this is going to be where we can do a lot more unique things. Now, interesting thing here is practical use in rigging for this. There's actually a lot of practical uses in rigging. Some of these sometimes are just making something a bit more usable. For example, if I select this control here, you'll notice I have a custom attribute here called global scale, and I'll probably get to showing you guys how to do these today. If I take the global scale here, I can middle mouse drag, and it should scale everything. Now, apparently I did not actually hook this up, which is hilarious. So let's take a look at how I would hook that up. I would come in here to my general editor and connection editor here. I would simply reload left. Custom attributes are always at the bottom. And I would find what I need this to scale. So I need this to scale the control group. So I'll reload right and just type in scale. And we'll go ahead and take global scale here. Notice it's a single channel output. Because this is just a value, it is a 0 to 1, I can hit scale here and I can actually connect to multiple channels. So I'm actually kind of glad this is broken. One of the other things about outputs that's great, constraints are 1 to 1, one attribute to one attribute, one object to one object. We can make this control all of these. So you'll see now that is controlling all of these in terms of the control. You'll also notice it just collapsed my entire thing here. I think that's because I set my global control here to 0. Probably should stay at 1, but you'll see how that worked. Now, the cool thing is this doesn't just have to control the controls. If you remember, controlling the scale of the controls doesn't actually do anything. I need to scale the joints too. So I can select my joint group, I can reload right here, access the scale, and hook this up to scale. And now the single global control input is controlling the scales of the XYZ of the control group, the XYZ of the joint group. So this hopefully gives you an idea how wild this can get, because that means in our little scene here, where I have this thing, you know, rotating and affecting this one object, I could introduce other objects for this to control. And not just that, I can introduce abstract things that don't really make sense. For example, why not try and control something like a light? So let's say I had a point light here. Lights have attributes. Can we control them? And the answer is yes. You can use whatever you want to control whatever you want with the connection editor. It's a wild space with no rules. If I reload right on this here, for example, we can go ahead and take a look at our light here. I could look for something like, I'll just do the translates on this for the, sake of speed here, but we could say this controls the translate X. So now when I rotate Z this, you can see the lights moving and the objects moving. So we can link whatever we want to that. So that's going to be a connection editor with different attributes. And that is the way it is most commonly used in my experience, more often than not. And when we need to do multiple objects, a lot of the times the connection editor is going to be the way to go there. All right, so that takes care of parenting, direct connection with different attributes, and then parent constraints. Now, this one here is an abstract one that is very rare. So this is doing a direct connection and having to invert it. So let me go ahead and give this a better context to begin with, so that way we can kind of understand what we might want to do here. I'm going to come in here to my general editor, connection editor, and let's go ahead and set this up so when I rotate it this way, these also rotate. So we'll connect the rotate Z's of these. We'll go ahead and find the rotate here. Rotate. And we're going to connect it into the rotate of this one. And we're going to take this one, rotate Z, and this one, rotate Z. And then I'll do the same thing here. We'll reload this one, rotate Z. Rotate. Why is this not doing what I want it to? Why can't I control your rotate Z? That's weird. Oh, because this apparently wasn't the cube. That would be why. Okay. I obviously need more caffeine. My 6-month-old did not want to sleep last night, so if I go incoherent at any point, I fully apologize. You'll see that I have this rotating, and it's rotating these the same way. So what if I wanted to make one rotate the opposite way while this one spins? And like I mentioned, this is a pretty rare thing to have to do. I've had to do it on a handful of rigs, sometimes asymmetrical rigs. It just really depends on how things are connected in. This is probably something we can talk about several different ways, but it's going to bring us into another editor. So what we're going to look for here is the node editor. The node editor is the craziest thing in Maya because it allows you to mess with the nodes directly and modify them in all sorts of different ways. You can think of the node editor as almost the the Omega editor of Maya. It can do pretty much everything. If we go ahead and open this thing up, it looks like this. It's not that intimidating to begin with. And you'll notice that what I have selected is loaded into here. Now, what I want to do, though, is kind of load in the things that matter. Now, I'm not going to get into every nuance thing inside of this editor. I actually don't know every nuance thing in this editor, but I'll talk about what you guys need to know. The first is going to be these here, and this is about all you need to know. These 3 things here. So what this is showing inputs and outputs. So this one here is the input icon. This one in here is the one we generally want to do. It is the input output icon. So it shows what's going in and what's going out. And then the final one here is the output. Now, what's significant, though, is what these buttons do is determine what we see here. When we open this up, we see this cube because we have this cube selected, and that's why it opened to this. But I actually don't want this cube. What I want to see is this guy here. The cone, I want to go in a different direction. If I select the input-output button here, what this is going to do is it's going to show me all the information going in and all the information going out. For those of you who have had the shading class, this probably looks just like Hypershade, very similar, same concept. Now, this little menu here is what we care about next, is kind of our attribute stack. You could think of it as a hamburger menu, I guess. It's not exactly a hamburger, but these are actually buttons. You wouldn't know that unless someone came in here and told you these were buttons. And all they do is reveal more attributes. So when you click on these, it's going to show the next layer of attributes. And what I usually do is just go full stack here so we can see everything, all three active, and what we can see now is our direct connection. This is another way we could visualize things other than the hypergraph hierarchy. You'll notice it's showing us a direct connection here. We can expand this further, and see exactly where it's going. So the hypergraph hierarchy, you know, that will show us a lot of other relationships like skinning and all that kind of stuff. This one's great for different types of connections. Now, the other thing that this is great for is we can access nodes in here. I did not learn about this menu until I was an advanced user in Maya, so I actually don't know how to do this in a non-advanced way. So I'm just going to show you guys how to do it. You hit tab. Tab is magical because tab allows you to search for nodes. So if you know what you're doing, you can find whatever you want. If you don't, somewhere in here's a node tab. I also want to mention, for those of you who have had shading and maybe have not seen this, you can do the exact same thing in here. You can hit tab, and let's say I wanted a file. You can find a file and you can pull this up. So these menus work identical to each other. If you know how to use Hypershade, you know how to use the node editor. Now, in this instance, what I'm going to want to do here is delete that file I accidentally created in here. I'm going to want to bring up some math. And in particular, I'm going to want to bring up an inversion or a reverse. Now, here's the really annoying thing. Depending on the software you're in, it's either going to be a reverse or an inversion. If I come in here and hit tab inside of Maya, if we type in reverse, you'll see there's a reverse. If we type in invert, there's not an invert. There's an invert lerp. So what I'm going to want here is a reverse. And what I can do is click reverse here to create reverse mathematics. Come into here, expand this. You'll see we have an input, we have an output. It doesn't really matter where we put this into. The most logical thing is to input into Z and to output into Z. Ultimately, all these mean is whatever's going into this slot is having its value reversed. So if I take rotate Z and input it into the input Z, this value will now be inverted. And this is the output of whatever is in the input of this particular input slot. So I'd want to take the output Z here and output it to the rotate Z here. And what this is going to do is it is going to make it so when I rotate this, that rotates in the opposite direction. But you can see how that gets that set up. So one rotates one way, one rotates the other. And the way we're doing that is by taking that direct connection, piping it into a reverse node, and outputting that into our new value. Now, this is also how we could solve the problem here of, as I rotate, this moves too much. If I were to select this cone here and use the input-output connection to access it, and then come in here to our lovely little menu here where we can find our connection, we could go ahead and alter that here using mathematics. So this is where I could use something like a multiply node, multiply divide to be specific here, but I'll do a multiply. And I could go ahead and output the values here to be different. So in this particular case, you know, we'll just take this input value here, and then we'll go ahead and actually, I think I need to find a different node. Yeah. Conversion factor. Let me see if that's it, 0.001. And then we could output that. And if I'm not mistaken, what that should do now is take this math here and multiply it by 0.001. And you'll see now it's not moving at all. So maybe not 0.001. Let me go into the attribute here. We'll set that to 0.1. And it will make it so rather than moving 1 to 1, it moves in a 0.1. So every time this moves, 100, that's essentially moving 1 unit. And that would allow us to kind of fine tune this and control this and essentially make this usable to where it would be practical. All right, so that is a super advanced technique using the node editor. You could also use the node editor to just do direct connections, but that's how we can invert, multiply, and all that stuff. Now, I do not have a practical example for those on this rig. So the reason why I mentioned that's an advanced tool is a lot of times you're not going to need that, but if you do, now you know, right? And you'll know basically if you know. It's just one of those things. All right, so we already talked about all the direct connects parent constraints. What we're going to talk about now is some of the other constraints that we have access to, the point, orient, and aim constraint. Now, I'm going to talk about the point constraint first because it's kind of a neat one. The point constraint's purpose is to basically track the position of something between two objects. So the scenario I have here is we have these two cones, and let's say we wanted this to stay in between these two cones. What I could do is I could select cone 1, I could shift select cone 2, and then finally select the object I want to keep between them, and just come in here and do a constraint, point constraint. And what this will do is whenever one cone moves, our little cube here is going to move proportionately towards that other cone. So essentially it stays between these points and has a lot of practical uses in that regard. Now, there are other really wonky things the point constraint can do that I don't have time to explain today, but it can also track a point on a surface as it rotates and other really weird things like that when you come in here and you start to change some of the settings. But as a base level, this is what it does, is it kind of maintains the distance between these two objects. And the way that I use that practically on our little character here is this glowing orb is actually point constraint in between these big orbs. So you'll, well, not big orbs, these big spires. You'll see as these spires move, that moves automatically. And what this does is kind of save some animation time for the animator and just kind of gives some rules for this to follow for the character and the off chance that, you know, this is how this thing's supposed to move. So that's kind of a practical example. The way it's being used is on those groups. So if I show you how this works in here, what we're going to need to do is select the control here. We're going to need to select the group above this and then select the control here. So if I come in and we look at this, let me find where this is. That's our orb group offset. We could select the control, shift select the second control, and then shift select the offset here. And then if I do that constrain point, what it's going to do is put that point constraint on that offset group. Like I mentioned, that's the purpose of it. So now it will move in between these. But what's really cool is you'll notice this doesn't have any animation. So if I wanted to change the position of this, I could do so. And that main group's going to maintain its distance, but we still have the ability to animate this independently if we wanted to. So it's a pretty nice little feature. So that's going to be point constraints. Very abstract tool. It has a handful of uses, and we'll actually be exploring some of those as we go. The next one here is going to be the orient constraint. The orient constraint is pretty straightforward. It constrains the rotation of one object to another, specifically that. So if I shift select the cube, shift select the cone here, and we do a constrain orient, what you're going to see is that this gets a box. Now you're going to notice it's not oriented correctly. I'll talk about that in a second. But if I reset my settings here, there we go, and I hit apply, you'll see that this will make it so when this rotates, that one rotates. What's cool is if this moves, that doesn't move. So you can have something that moves but doesn't make the other thing move. Now you can do this exact same thing with a parent constraint, which is interesting to note. What is unique about the orient constraint is the ability to do things like offsets here, and the fact that the word orient means different things. So the orientation of an object is kind of baked in. By default, all of these have the base orientation of their object. But when you get into joints, joints can actually have different orientations. With that said, this is one of the constraints I've never used in a professional capacity. So I don't really know what to say about orient constraint that much, simply because I've literally never used it on a professional project. So it's one of those things that doesn't really need to get touched. However, it has some sort of a purpose. The next one's going to be the aim constraint. The aim constraint is kind of cool because it aims things at things. So for example, let's say I wanted to aim this cone at this cube. We could select the cube, or is it backwards for this one? We'll find out. It might be backwards. But I'll go and select the cube, select the cone, and just do a constraint aim. And what that will do is basically as I move this, it's going to try and aim at it. Now, you might notice it doesn't quite look like it's pointing there, so there are things that we need to adjust, which is kind of a weird factor of the aim. So you select the target, shift select what you want to point at it, and the aim has a whole bunch of options in here. There's an aim vector, there's an up vector. The aim vector is where it is pointing. These are denoted in X, Y, and Z. So if I wanted to try and get this to point at the cube, I could set this to 0 so it's not on X it's aiming, and set this to 1 on Z so it aims on Z, and try applying that. Still not going to work because I need to rotate the object, but, you know, that's the base idea there. So we'd have to play around with it for this exact scenario. I also think I just simply have to rotate the cone, if I'm going to be completely honest here. If I just break the connection here and rotate this 90 degrees and go ahead and freeze this, and then I select this and shift select that and aim, that'll make it so it points at it. So this is really good for things like guns, like tracking guns for like a turret head, or other areas you might use this on is for controls for like a head control. For my weird little character here, I set up an aim control on this base here so that as the character moves, that little base control always points at the ground. So you can see as this character moves around, I don't need to manually control that. It's always going to be pointing at the ground. Specifically in this case, it's pointing at the start point where this character came from. Ideally, I'd probably want to make that something I can control, but hey, there you go. That's the aim constraint in action on this character, allowing us to have some secondary animation just from moving this thing. So that one's practical. I use it a lot for really random stuff like that little foot there, but like I mentioned, it can be used as well to kind of create a head aim control. So a character's head rotates at a controlled target and you can make it look like a character's staring somewhere. The last one here is the scale constraint. This is another one that I also never use, but we can basically take one object, shift select the other, and if we do a constrained scale, it's going to constrain the scale. And as you might have guessed, if this gets bigger, that gets bigger. Why don't I use that? I tend to just use direct connections. The only reason why you would use a scale in particular is the fact that you can toggle these on and off. And I haven't talked about this yet. We're about to get to it. But if you select a constraint, you'll notice that it has this attribute here that has a W. And if I go into any of these, there should be some sort of an attribute with a W here. And you'll see all of them have that. Now, what that W stands for is weight. And what weight means is the mathematical contribution of the effect. So in terms of having a scale constraint, the only advantage is the fact that you can adjust this here. So if you wanted it to do like half scale, actually I take that back. This only works with multiple scale constraints. So it won't even make sense till the next thing I show you. But you notice if I toggle that on and off, it basically disables the constraint, right? It acts as an on-off switch. Now it's technically a blend switch, but only if you have multiple constraints on an object. But that is the only time I would use a scale constraint, is if there was some reason to do that. So I have never used a scale constraint in a professional capacity. So yay, fun facts. So that's going to bring us to the final constraint thing here to talk about, which is going to be when you have two constraints controlling one object. And for this one, I'm just going to show it with parent constraints to make things simple. But let's say we wanted this cone to be able to control this object, and we wanted this cone to be able to control this object. What we could do is we could select cone A, we can shift select cone B, and then finally select the object we want them to control, and we can perform a parent constraint. Now, what's unique about this is if we take a look at this, you'll see there is a single constraint created. And this is important because that weight I just talked about, if it doesn't have something to return to, it acts as an on-off switch. But if it has something to return to, it acts completely different. So by default, when an object has multiple constraints on it, it acts almost like a point constraint moving between those 2 points. So you'll see this is very similar. Now it's technically different behavior, especially since it also rotates in halves here, but you can see how that works. Now what's significant here is this weight on each of these can be altered. So for example, if I reduce one of these to 0, it is now this object that fully controls this, and this other object does absolutely nothing. But if I go ahead and switch this, so this is back to 1, and this one goes to 0, now that one's in control. And as you've probably already noticed as I'm switching these, if I do fractionary control, like this one gets 0.5 and this one gets 0.1 or 0.2, it's going to be partially controlled. So there's a lot of interesting practical applications for these that I probably have never used, but I do use this a ton in rigging for on-off switches of various sorts. So what I have going on for this one is these spires. These spires I currently have set up on this to follow with the body, but let's say I wanted the character to die. Instead of having them follow with the body, I could switch these and I could have this follow with nothing. So that way it stays in place. And the way that I've achieved that is I have this locator in here called world, and we'll talk about these later, but this is a locator that essentially never moves. It stays at the base of the world and it keeps its position. And then I have the torso. So if we take a look at this control here and I expand it out, you'll see that it's weighted between the torso and the world. And what I've set this up to do is when it's set to 10, it transitions to be weighted with the world, and when it's set to 0, it transitions to be weighted with the torso. So that allows me to create the effect of it following with the body or following to the ground. So that's a practical example there, and there's a lot of uses for that. Now we have two more things to go through. That's going to be set-driven keys and expressions. So these are once again more advanced things. So let's get to set-driven keys. Set-driven keys are also abbreviated as SDKs, and they are a way of actually baking animation into controls. And this can be very useful because it allows us to do a lot of interesting things. Now, in terms of this, I might actually do a different example, but I'll create another thing too, just for fun. We'll create a directional light. And let's do a directional light. There we go. Just to kind of show a little bit extra. And I'll go ahead and turn this on because let there be light. Cool. All right, so set-driven keys are weird because if you come under your Windows here and animation, you're not going to find them, and I don't know why. And if you look all over this place, I don't think you're going to find them anywhere on the rigging menu. Don't know why. People who build Maya don't use it. Set-driven keys live on the animation menu. There you go. And they're going to live under the key menu here. So under the animation menu, under key, you can find this option here called set driven key. And we're going to navigate over here to this menu called set. And if you go ahead and click on that, it's going to pull up this weird looking menu here. Now, this is another menu that uses a driven system. And what it allows you to do is essentially keyframe values to affect other values. So for example, if I come into this cube, I can load this as a driver. Down here's how I normally do it. Just click load driver and it will load it into there. And then I can select this one here and I can load driven. What that means is my cube is going to use these attributes here to affect this object. Now I'm going to take the direct connect scenario I showed you guys earlier and kind of bring it to a more practical sense. For example, if I say this thing's rotate here, rotate Z, when it equals 0, this thing's translate Z equals 0. I could go ahead and select that. So rotate Z, translate Z, and I could click key. And what this does is it actually sets a keyframe in sort of a backlog data setting that now says that when this is at 0 here on the rotate Z, that is also going to be at 0. Now, we haven't achieved anything yet, but I can show you that if I take this here and translate this and we move this at all, it snaps into place. So we can confirm that's working. The other thing to be aware of is notice there's no colored stuff on the driver's channel box, but on the driven, it turned blue. Now, what I can do here is I can indicate some sort of a value. For example, I could rotate this a certain amount, like let's go ahead and rotate this 180 degrees. And we can say when rotate Z is 180 degrees, we're going to move this inwards here, and we're going to make that touch there. So I'm going to take that rotate Z or translate Z and set it to 4. And what I can do now is click key, and what this will do is it will make it so rotate Z as it goes towards 0, that moves away, and as it goes towards 180, it pulls it back. So I can actually set very specific values with the set driven key to make this relationship happen. You can also do very exotic things with this, which is one of the things I want to show you. So for example, I have this directional light here. I could load this as a driven. I could make this drive the value of this too. So we could change the light rotation. I could also make it toggle visibility. So this is kind of a really random thing, but let's say when this rotates this in here to 180, I want it to go invisible. I could go ahead and set that to 180, select my light here, set its visibility to 0 and hit key. And then let's say at 0, I want this to be visible. I could come into this light here and set the visibility to 1, and we could hit key. And what that will do now is as this pulls in, it will turn off the light. As that pulls out, it will turn it back on. So you can essentially use this to create something like a literal light switch where when it's flipped up, the lights are on. When it's flipped down, the lights are off. So that's kind of a neat little factor. Set-driven keys, where are they being used on this guy? Good question. They're being used for these on-off switches. So this follows with I showed you. This is being controlled by a set-driven key, making it so this either follows with the world or the body. And that's one of the most practical uses we make of this, is turning things on and off. Now, what this also is in control of is a very special dial that I'm about to show you, which is controlling my expression data. If I hit play on this character, you're going to notice there is no animation. So right now it's animating. But if I come in here and I use this set-driven key I've set up to auto float, and I set that to 10, you'll see all of a sudden this character is auto floating. Our animator doesn't have to animate that anymore. It's built in. So what I want to talk about next is a very powerful tool called expressions. They're very powerful, but they also are rare in the respect that most of the time you don't need to use them. Now, I want to show you guys how to get this set up, and I'm going to talk briefly on the expression editor, but I'm not going to get super in-depth into it. So let's go ahead and get to that real quick here. The expression editor is going to live under our Windows menu. It's going to be under our animation menus and expression editor at the bottom here. So if we go ahead and open this up, it is going to look scary because it kind of is. Now, what this is here is essentially a place we can add code to our objects in the form of constraints. What code do we add? We add mel code. So what we can do here is we can select an object to add to this. Now, the very last one here under the expressions group is the designated one for this. But what this allows us to do is basically come into our object here, take a look at its attributes here, and then we can select one of these objects to manipulate. Now, I do want to just emphasize this is taking a look at what expressions are and what the expression editor is and giving you a context. This is by no means a crash course on this tool. This would take up an entire class in itself. But what we can do here is we can decide what we want this to do. And I'm going to show you exactly how I set it up on my character. I made an auto hover here, which means I needed it to control the translate Y, the up and down movement. So what I can do is select that here. Now you'll see here, select object and attribute. It says auto hover translate Y, and then it says default object auto hover and cover units, all none, angular only. We're not going to worry about that. What we care about now is the expression. The expression is what we make this do. Now, this is the thing we're going to affect, so you can generally just copy this and paste it down here. And then what you need to know is mel code. If you type in mel code into Google, you'll see Mel for Programmers Help. There's all sorts of fun stuff. This is the code that is running Maya. And when you look in here, for example, this is all Mel code. Everything you do is Mel code in Maya. So there are some really useful things you can do in terms of Mel code. For example, you can access things like sine. Sine is basically a sine wave. That's the up and down movement. And that's what I essentially want to have. So for example, if I says equal sine here, that will go ahead and make this equal a sine wave. But we need to give it something to equal to, which is going to need to be equal to time. So I'm going to input this to time by putting it in a bracket, whatever that thing's called. I don't even know. I'm going to give it a multiplier of 2, so it's 2 times time. That way we're getting something a little bit faster. And you have to end it with a little semicolon here, and you can click create. And if I hit play now, what this should do is move up and down. So what we've essentially done is we've made that equal to, sine of time times 2. I could edit this as well. What if we just made it equal to sine? And I clicked edit here, you'll see I get an error. That's because sine needs to have time as an input. If we go ahead and just make it equal to time, you'll see that's the effect it's getting. But we can add a multiplier. If I add times 20, what you'll see is that makes it go faster. So times 2 is going twice the speed of time. But then we can further modify this in terms of amplification. So what this is doing is it's moving up and down, time is the rate. The amount it's moving, though, we might want to control. So for example, if I wanted to make it higher, I could add a multiplication point and I could set this to something like 10 and click edit. And what this will do now is it will make it 10 times the height. Or if I wanted to make it smaller, this is a float value. So I could set it to something like 0.25 and I could click edit here and hit that. So it goes 0.025. So this can be very useful for really any repeated task. The way I've used this before is for like Ferris wheels and backgrounds that I don't want to need keyframes for. I just want to animate at a consistent rate. You might use it for environmental props like a water wheel, a windmill. Both of those are excellent examples. Anytime you have like a floating object like this, this is a great way to go. I do want to talk a bit about the Mel side of things. I don't work with Mel code much. Honestly, in a professional capacity, I've like never had to touch this stuff. They always harp about knowing code and all that kind of stuff. But that's where ChatGPT comes in. So how did I make this script? No, I didn't come up with that. I use ChatGPT. So let's say you guys wanted to make a Ferris wheel, like I mentioned, spin infinitely. Let's go ahead and rotate this. Oops, let's get that 90 degrees. So this needs to rotate on Z. I'm going to name this wheel. And let me go ahead and just give these some extrusions so we actually see something here. Show you guys a cool modeling trick if you guys have never seen this before. If you guys come in here and use an extrude, edit mesh, modeling, edit mesh, extrude, go into the options here. We'll just hit apply. If you toggle keep faces together to off, rather than pulling them all out like this, it will pull them out individually, and you can get cool little wheel spokes like that. So, fun fact if you guys have never seen it, but that's going to give us something to look at. So what I want this to do is I basically want to rotate this on Z. So I could come up to something like ChatGPT and just say, you are an expert at Mel code and Maya expressions. I have a wheel that I want to make rotate automatically with time on the rotate Z axis. And you just need to know what an expression needs to know, essentially. It needs to know the object name. The object name is wheel. Write me the Mel code for this expression. And you can even have it give you directions on how to set it up. This is how I program now. So for all those people that went to school for programming, yeah. So you'll see this one is using frame instead of time, so that's kind of interesting. If you want it to spin per frame instead of per second, you can use frame instead. That's kind of cool. Wheel rotate equals time times 360. So I could just go ahead and copy this here. We could set that up, wheel rotate Z. Paste this down here, hit create, hit play. Ta-da! Yeah, I'm not going to teach you guys how to code. Don't go learn how to code. If anyone tells you to go learn how to code, slap them and then go show them this. That's how I make expressions now. It's really cool. I didn't used to use expressions a lot. I might now just because it's so darn easy. But as long as you kind of understand the base logic that you're taking an object's name, you're taking an object's attribute, and you're modifying it some way, making it do something, that's how you can basically get it set up. All right. So that's going to be the final thing here on expressions. Okay. Like I mentioned, I've hooked it up here so that this has a auto float to talk about a little bit of what's going on under the surface here. This here is what the expression is attached to, this locator. And then, as you might have guessed, this here, this auto float, is controlling the weight of a constraint. So there's a constraint on the offset group of this controller between the auto float and the world. And essentially what happens when I uncheck the auto float is it goes back to following the world, but that little thing's always there, always floating, which is kind of cool. And anytime I want to bring it back on, I can do that. So for example, when it dies, it probably doesn't auto float. So that's the reason why I need that there. But for background objects like Ferris wheels, water wheels, any sort of spinny thing, little wind wheels, whatever those things are. This is a cool little trick. The other thing that I want to mention is if we come into Hypershade, where's my Orb of Doom? I'll just click the Orb of Doom. There we go. Now let's get a Lambert because I'm lazy. You can attach expressions to these. If I come into something like the color here, for example, of this object, and I right click, you can see create new expression. And you can actually link in the blend color. So let's say I wanted to set this up in ChatGPT because I don't know how to code off the top of my head. I need an expression to make blend 1's color change with time to a random color. This will go ahead and give me some code to make that happen. So yes, I'm very lazy right now. So continuous random, like change smooth animated colors, it gives me this. I think only one of these is needed now that I think about it. Nope, we need color RGB. So this will give me random color. I can just try whatever one of these I want and just input that in here and just hit create. And yeah, let's just name this our random, and we'll go ahead and place this on here. And I actually don't think this even needs time, which is kind of weird. It is literally just changing color, literally randomly, and I'm actually not really sure what's controlling that. So definitely use it responsibly. That hurts my eyeballs, but that is pretty cool. So you can do some really weird stuff with expressions. There are practical things like making it move with time. These obviously here aren't the most practical things here. But there are some cool menus like that that we can kind of alter here. That's interesting. It separated these out now. I might have to play around with that, but I'll leave it there for now. So you guys get the idea. Be sure to like and subscribe so you can catch the next video in the series when it goes live.